दिखते मैडम पढ़ते बराबर स्टूडेंट पढ़ते बराबर
भेजने का है अभी. Good morning, all of you. Today we have to perform the experiment number to determine the flexural rigidity of simply supported beam and compare it the value, experimental value and theoretical value. Now see, this is our simply supported beam, this beam. Okay, this beam is our simply supported because the beam it is removed and this two supports is there and the beam which is rest on these two supports. Okay, now as per our the methodology, that is as per Maxwell reciprocal theorem, if simply supported beam and point load acting at center, you can directly calculate their deflection, and that part we have to cover in our theory lectures, that deflection which is equal to WL cube upon 48 EI. So that is our theoretical value, and we have to check here whether the experimental value which is match our theoretical value or not. So how it can be measured? By using this dial gauge is there. Okay, so using this dial gauge, the least count of this dial gauge is 0.01, and we have to measure here at least 25 mm deflection. Okay, and this is the center of our beam. The span, the length of that beam is 100 centimeters. So the center which is located at 50 centimeters. So by using thread, first of all you measure the dimension of that beam, that is the width, thickness and length of that beam. But it is directly given to you in our manual, isn't it? Because the beam it cannot be changed. So naturally the dimension it cannot be changed. Now see here the dial gauge. Once I apply the load here, see here the dial gauge which is goes on anti-clockwise direction. So what is the meaning of that? If our deflection is goes on downward side, naturally that deflection value it is our negative value. Now see here the internal dial gauge is also given to you. Why it is given? The importance of that internal dial gauge. For example, suddenly I applied here load, isn't it? You have to see this is our the hanger. Once we have to apply here load, so naturally the beam it will be deflect in this way, isn't it? Downward side. So see here, suddenly I applied here load, and for example, this outer dial gauge, the needle is there, it is suddenly move, and we don't know at exactly what amount, what number of cycle which is considered here. So for example, see this is 0, and if you it is like the 10, 20, 30, 40, it is 100. If one circle, if one revolution is complete, so that inner dial gauge, so for example here it is considered as 16, and if it is complete one revolution is there, so it is circulate up to 17, like that. So it depends on whatever amount of load you have to apply here, isn't it? This is very simple practical. Now I apply here the 100 gram of weight. You have to convert that load into Newton, then you have to calculate your deflection. 100, 200 gram, 300 gram, 400 gram, 500 gram, like that. कितना है? So we have to start with 200 gram, then 100 का नहीं है. Now see here how it can be measure that load. Now see the dial gauge which is set at 0 first. This is very sensitive. So this is our totally loading frame is there. So you don't uh, raise your hand, touch your hand in any. So I said the dial gauge. The dial gauge is very sensitive. If you see, the just touch that beam, it is also rotated. I just set it at 0, so you can measure your reading easily. Otherwise, if it is so, see if it is in set at a 10, so naturally, see this is 10. Now I apply the 200 gram of load, and you just note down your reading. Now see here, 10 up to 81. It is just goes on anti-clockwise. So you have to measure at distance. What is the distance? 10, 20, and that is 30. That is your reading is 31. 31 multiplied by your list count. List count is 0.01. This is your first reading for 200 gram. Clear? Similarly for, you have to again apply for 300 gram or 400 gram. Now again for, now instead of adding that load, you have to at a time add 400 gram. Then you have to note your reading. Now see here, for 400 gram up to, it is from 10 to 40. So you have to measure 10, 20, 30, 40, 50, 60, and this is 69. Okay, 69 multiplied by 0.01, that is your another reading. Clear? Similarly for 600 gram. See again, that dial gauge is again set at 10. Now see here, one complete revolution is complete. Means that for 600 gram, your deflection is 100. 100 multiplied by 0.01. Clear? Similarly for one more reading we have to taken here, that is for 800 gram. We have to set here again for 10 in this way also. Okay, so I again apply the load for 800 gram. So check it. Okay, one complete revolution, and then additional is this, that is 10, 20, 30, and this is 34. So that number of readings is 134. Isn't it? So you have to note down your reading for the 800 gram of weight. Clear? Yes, so you have to see here the application of our load, that is at center. Yes, so this is our totally loading frame. You have to see here loading frame. Yes, this is our material is steel. So what is our modulus of elasticity for steel material? That is 2 into 10 to the power 5. How it can be calculated? I value. This is our rectangular section. So I value is BD cube by 12. Clear? So in this way, you have to calculate directly our flexural rigidity. Flexural rigidity, that is the product of moment of inertia and modulus of elasticity. You can directly calculate flexural rigidity. That is our value of EI. Clear? Okay.